Kinetics, lesson number 6, enthalpy and enthalpy change. Enthalpy is denoted by the variable capital H, and enthalpy change by the variable delta H, delta signifying change. Enthalpy is defined as the heat content of a substance, the total kinetic energy and potential energy of a substance at constant pressure. Delta H is a value that can be calculated by taking the enthalpy of the products, subtracting the enthalpy of the reactants. When we think of the energy changes that take place in a chemical reaction, there are two types of changes taking place. We have a case that is endothermic, and we have a case that is exothermic. The definition of endothermic is we have heat is absorbed from the surroundings. Chemical equation, reactants plus enthalpy to produce products. For exothermic, definition is heat is released to the surroundings. Chemical equation here, reactants to products plus enthalpy. Let's graph this out, starting with endothermic. X and Y axes here. On the Y axis, we're going to graph potential energy, units of kilojoules. On the X axis will be reaction progress. Reaction progress means as we go from reactants to products in the forward direction. If we start here at reactants and products are here, the graph would look like this. If we come across here, this value here is our delta H. We are increasing in energy in order to form products. Our delta H here, our enthalpy is greater than 0. For the exothermic case, we have again potential energy in kilojoules, reaction progress, reactants, products, and in this case, our delta H is going to be releasing energy, and here our delta H is going to be less than 0. If we look at this in terms of equations, if we see that our delta H value is a negative value, the negative delta H means that we have an exothermic chemical reaction. If we see that we have a positive delta H value, a positive delta H means we have an endothermic chemical reaction. We can also write this in thermochemical form, where the enthalpy is included in the chemical equation. If we see that enthalpy shown on the reactant side, that means we have an endothermic chemical reaction. If we have enthalpy shown on the product side, that means we have an exothermic chemical reaction. In the first case here, if we were to pull out the enthalpy, we would say that this equation here would have an enthalpy delta H equal to positive 201 kilojoules. And in the second case, since it's exothermic, the delta H here would be equal to negative 296 kilojoules because it is exothermic and releasing energy. But in a chemical equation, it's always shown as an addition. The Hebden assignment for this lesson is page 16, numbers 24 to 28.